Could AI break Nvidia's silicon monopoly? Nvidia currently stands as the undisputed leader of the AI revolution, a position reflected in its staggering multi-trillion-dollar market valuation. However, the very technology Nvidia helped pioneer artificial intelligence may soon be the tool that dismantles its competitive advantage. The industry is seeing a shift where AI is no longer just the user of hardware, but is increasingly becoming the architect and optimizer of it. The software moat under siege. Nvidia's dominance isn't just built on raw power. It is built on programmability. While many competitors offer chips with similar theoretical performance, floating point operations, Nvidia has a massive head start in software. Their specialized libraries and tools make it much easier for developers to write code that runs efficiently on their hardware. This has created a high barrier to entry. For example, when Anthropic moved to run its Claude models on Amazon's Trainium hardware, the company had to rewrite its code from scratch to ensure efficiency. Enter Wafer, a startup aiming to bridge this gap. Wafer is using reinforcement learning to teach AI models how to write kernel code, the low-level software that talks directly to hardware. By automating the optimization process, Wafer aims to democratize efficiency, making it easier for non-Nvidia hardware, like AMD or Amazon's chips, to run complex AI models, reduce costs, minimizing the need for highly expensive, specialized performance engineers, maximize intelligence per watt, ensuring that hardware isn't just powerful, but highly efficient in how it uses energy, automating the blueprint, AI in chip design. If Wafer is optimizing how software runs on chips, another startup, Recursive Intelligence, is tackling how the chips are built in the first place. Chip design is one of the most complex engineering feats on Earth. It requires arranging billions of components on a tiny piece of silicon, and then undergoing rigorous, iterative testing to ensure everything works. Traditionally, this requires massive teams of human experts. Founded by former Google engineers Azalia Mirhosini and Anna Goldie, Recursive is working to automate the long poles of the process: physical design and design verification. Their vision includes natural language design, using large language models, LLMs, so engineers can describe changes or ask questions about a chip using simple text. Accelerated iteration, using AI to optimize the layout of components, a technique previously pioneered at Google. The scaling law for hardware, the potential for a recursive loop where AI designs better chips, which in turn provide more compute to design even better chips. Why this matters? The shift toward custom silicon. The tech industry is already moving toward custom silicon. Giants like Apple, Google, Amazon, and Meta are all developing their own proprietary chips to tailor hardware specifically to their software needs. Historically, the bottleneck for these companies hasn't been the hardware itself, but the massive software and design effort required to make that hardware perform. If AI can automate both the design of the chip, Recursive, and the optimization of the code, Wafer, the moat surrounding Nvidia begins to evaporate. The moat lives in the programmability of the chip. I think it's time to start rethinking whether that's actually a strong moat. Emilio Andier, CEO of Wafer, conclusion: the rise of AI-driven chip design and software optimization represents a fundamental shift in the semiconductor industry. If AI can successfully automate the most difficult parts of hardware engineering, the barrier to creating high-performance, custom silicon will drop, potentially ending the era of single-vendor dominance in the AI era.